Hello, this is Stephen Neshiba, and I'm back to help you out with exercise. So here's the idea is that what we want to do is create this thermodynamic surface pressure as a function of volume and temperature over a certain volume range, the same volume range that we did before, but now we also want to give it a range of temperatures. And I've gone ahead and downloaded ts3.py from the website. And there it is, and so let's go straight to Canopy, and here's TS3 that I just downloaded. Now you'll notice that there's there's another resource here. This has to do with plotting things in 3 dimensions, but apart from that, things are fairly similar. Now you notice here that this line right here, I've indicated that I want a range of temperatures, and here's a range of volumes. The volume range looks okay to me, but if you look here, I wanted 250 to 300 Kelvin for the temperatures, so I'll have to change that. 250 to 350. And let's see what else. Now there's another piece of the graphics that's going on here. This is the usual boilerplate setup, but this command here sets up a graph in 3 dimensions, and this command here will actually do the graphing. What it's going to do is on the x-axis put the volumes, and on the y-axis it will put the temperatures, and on the z-axis put the pressure. And there's some annotation here. So I think this is good to go, and I'm going to go ahead and run it. And so let's see if it will come up with some graphics. And there is some graphics here. Now you can rotate it by using your mouse button. And as you can see, there's temperature there, there's volume there, and pressure on that axis. Now, well, that's pretty much what it is. What I really want to do is kind of discuss a little bit more with you than the result of this mesh grid command, which I kind of skipped over. So remember that when we created the volume array, that was 50 points from 10 to 40, and then similarly the temperature array was 50 points from 250 to 350. But what we really need, as you can see from that graph, is pressure at all possible combinations of temperature and volume. And that's what this mesh grid, this numpy.meshgrid command does. It says here's a set of volumes, here's a set of temperatures. Give me an entire grid of volumes and temperatures over that whole space. Now I printed that out here. Let's see, when the shape, in this case, I asked for the shape of the volume grid and the temperature grid, and you can see that each one of those is 50 by 50. That's the shape of the volume grid. And there's the shape of the temperature grid. And I asked it also to print out the volume grid. So the volume grid, every column is a different volume, 10, 10.6 up to 40. But the rows don't change. That's because now when we look at the temperature grid, you can see that every row of the temperature grid is now changing, but each column is the same. And so that combination, which is created by meshgrid, produces that whole grid of volumes and temperatures that we want. And then, of course, pgrid, because it acts on both of those, gives a new grid of pressures. And in fact, if you want, you can go right here in the command window and say, you know, I want to know what variables are out there. Okay, that's all these variables. And if I'd like to know what is the shape of the p-grid, I can just say np.shape of p-grid, and it should be a 50 by 50. So, okay, well, that is pretty much what we wanted to do on exercise 3, create the thermodynamic surface, and then I have some analysis that I'd like you to do.